So this is about non-parametric method. So whatever you have learned before, they are all about parametric. Parametrics and non-parametric definitely are two different methods. So in non-parametric, we don't really have any assumption. Well, parametrics is a very strict methods of statistics. Means that for parametrics, you have assumptions of normality. Your diagram, your curve should be normally distributed, and then you're gonna have a certain sample size, like at least you have to have 30 and above. The more the better. But non-parametric, you can have a small sample size like 10 or whatever. Okay, and yeah, there are also many other assumptions for parametric, but for non-parametric, you don't have that. It is a very, what we call a very lenient, less strict with all these kind of assumptions. Okay, and in this case, we want to look at the nominal level. Like you just want to focus on the nominal data. It can also be talking about other level of measurements like ordinals, fraction, and everything. But we just, for the sake of your study, we just want to focus on the nominal. Okay, so I don't want to explain what is nominal because I'm assuming that you should know what it is. Okay, so under non-parametrics, what do we have? Well, there are like 5 formulas here. So first, you're gonna have population proportion. Okay, so under proportion, so you should be able to distinguish between one sample and two sample, and then you're gonna have goodness of fit, and you should be able to distinguish between equals and unequal expected frequency. Okay, remember when you talk about goodness of fit, you are looking at frequency. Okay, some people are confusing. Should I use the formula of proportion? No, proportion. If you want to use the formula of proportion, you have to have x and n. X means your observation, n is your sample. Okay, and then contingency table. Here you want to look at the relationship between these two, whether they have negative or positive or not effects. No relationship. So relationship. Okay. The previous one, proportions and goodness of fit, you are not interested to look at the relationship. Okay. So yeah, so let's look at your question. Which one that I have asked? Okay. So this is what yeah, this is section 5. So let's solve this question together because I also not sure about the answer. So let's look at it. Okay. Okay, the first one is IIUM plan to reward their graduates. One of the 3 gifts during their graduation ceremony. So normally when you are almost completing everything and during your graduation day, you will get something like a tokens of, not really appreciation, like a gift as a remembrance of the university. So you have to decide. I mean, they are planning to give 3 gifts, whether a marks with IUM logo on it, a T-shirt, okay, with IUM logo as well, or IUM car sticker. Okay, so IUM wants to know whether the 3 gifts are equally well liked. Means that if let's say we offer these 3 gifts, will students prefer them equally the same? Or maybe some of you, maybe everyone's just want to have the IUM sticker and the marks, maybe no one interested in it, or T-shirt maybe, I don't know. Okay, so if let's say the university wanted to know this, okay, so they conducted a study, right? So in a samples of 500 graduates. So what is this 500? Tell me. What is it? And okay, also why should I put equal? Yeah, it should be equal. And then what else? The number of selecting. Okay, each gift is reported below. So you have everything here. So at the 0.05 significance level, compute the test statistics. So you are given alpha 0.05. So is this question asks you to solve everything? No, right? You are asked to compute the test statistics only. So what is this? Is this proportion? Is this what we call what is it? Goodness of fit test? Which one? Which one? Is it contingency table?
Goodness of fit.
Goodness of fit. Okay, so you don't have, if you, okay, you will look at the question later on for proportion. Here you don't have the details for proportion. You should be given the percentage or pi. You should be, there are many other things as well. Okay, in this case, it is the examples of goodness of fit. So which one? Is it equals expected frequency or unequal? So is it
Equal.
equals?
Equal.
Equal.
How do you know it is equal?
From the
Because we are expecting that these three are equally well alike. Okay, so let's see. So how to compute the test statistics? Do we have a formula for that? What is the formula? I don't remember. So this is equals, let's see, to sample knob. Goodness of fit test. So this is equal, right? Okay. Okay, so in this case, you have to compute. So what kind of test statistic should we use here? Is it t-test, z-test, f-test? What test?
T squared.
Anyone? What? We call it chi-square. Okay, make sure that the pronunciation is correct, chi-square. Make sure that when you have graduated from statistic class, you know how to pronounce it. It should be chi-square. Okay, so we have to, for the goodness of fit test, we have to use chi-square. So what is the formula for chi-square? You have, okay, let me just, where should I write? Here. Chi-square equals to summations of all this. What is OF? Observed frequency minus expected frequency, and then observed minus expected, and then you square it over expected frequency. Okay, so you have to solve the top one and then the bottom. Okay, so this squared belongs to the top one. Don't square everything. Okay, because I've seen my students, they square everything. They put observed minus frequency minus expected, and then divided with expected, and then squared. No, the squared only applicable to the top one. Okay, so this is the formula. So if you look at the what we call the slide, they make a table so that you can see everything clearly. But it's up to you. You can just have like this, like you have to observe whatever the number minus the expected, and then put squared, and then you have plus blah 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 over the expected. So depends. Okay. So maybe I should just write like the slide so that you can, yeah, both are fine. Okay, so let's see if, let's say, we want to should we use like the slide, or you are okay with whatever? Which one is better? You want to present it in a slide form, or just observe minus expected plus blah 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 over expected? Which one do you prefer? Okay, maybe like the slide so that you can see clearly. Okay. Okay, so let's see. Okay, let's just try to apply the 1, 2, 3, 4, 5. You don't really have to draw this. Like 1, 2, 3, 4. Normally, I will just compute it like straight away, but just to show that. Okay, okay. So the first one is that this whatever. So we have the observed frequency and then expected frequency, so that you can see clearly, and then the observed minus expected, and then the observed minus expected, and then you're going to have squared here, and then the final one, which is applying this formula. Okay, so you don't really have to do this, but that's fine. Let's just put it this way. So what is your observed frequency? Tell me how to write it. Observe means that the data that are given to you, and then you can observe them. Okay, so this is your x. Observed frequency means that the x, the one that you can observe. So this is the frequency that you can observe, right? So you have to write 1183. If let's say you happen to write 1175, don't worry, I will come up with a new answer sheet for that. So it's considered correct because you have seen this. If let's say some of you managed to solve like 175, well, that's fine as well. That's fine. Both are accepted. I will adjust accordingly. And then you're going to have 142. This is the observed one. So how to compute the expected? Because normally in goodness of it, the trickiest part is to find the expected value. If you are able to find the expected, everything will be easy. So how to find the expected? Anyone?
500 divided by 3.
What divided by 3?
500.
500. Okay, cool. So basically in samples of 500, right? So you can see that the totals of all these samples should be 500. So if you have 1000 here, it shouldn't be 1000 because in total it should be 500. But don't worry, it's okay, it's fine, it's fine. Okay? So the total of this should give you 500. So because the question said that IUM wants to know whether the gifts are equally preferred or equally well liked. So we assume that the expected value should be equal for all these three gifts. So how to make them equal? So you take the total sample, which is 500, and then you divide with 3 so that you will get equal amount. So what is the value? Anyone?
166.67.
166.67. Cool. 6.767. Okay, I don't have to compute it. So, yep. So you have to put 166.67. Okay, for 166.67 and 166.667. Okay. Now, the second part, well, basically it's easier to just compute straight away, but that's fine, so that you can see all the steps. The second part is that your observed frequency, which is this one, minus expected. So 183 minus 166.67, and then you will get this value. Okay, if you just go straight away and then put it in your calculator and then put squared, and you will get the answer straight away. So if you do this, you will get the value of what? I don't know. Anyone? Have you computed this way? No one? So let me see, because the textbook love to use the all like the long working, which I don't really like. But I'm afraid that you will use it. So yeah. So if you use like observed minus expected, you should get 16.33, and then if you put squared into it, you will get 1.6. And then later on, if you want to divide with the what we call expected frequency, you will get this value 5.6679. Okay, so yeah, as simple as that. Okay, so you just have to, yeah, whether you want to make it as a table or you want to compute straight away using this formula, they will give you the same answer. For those who get who use 1175, then you will get different answer. As long as your working is correct, so I will consider that. Okay, so that is your chi-square. Okay, so any question regarding this? It's like straight away applying the formula, you will get it. Yeah, simple as that. Okay, anything else you want to ask? Is it clear?
Clear, madam. Clear, madam.
Yeah, because the question was very direct and easy. Okay, next question is this one. D. Okay, okay, so should we go straight away to the next one? Yeah, don't worry, it's fine. Oh, maybe I should show you how does it look like. Okay, so in your previous question, I only asked about I didn't even ask the hypothesis. I just asked you to compute the test deficit because I think that it may take some time to compute them. It shouldn't, but just in case. It means that because you are asked to compute the test statistic, which is chi-square, so you should be able to submit it within 10 minutes. Okay, so the real question is that at the 0.05 significance level, is there a preference for the gift, or we can say that can we conclude that the gifts are equally well liked? This is the real question. Okay, so well, the same things. Well, this is the hypothesis testing, so you're gonna have 6 steps. You have to derive the hypothesis. Then the step 1. Okay, for step 1. Okay, so how to state the hypothesis? If you have this, how to state, how to do it? Anyone? Oh, this is twofold. How to state the null hypothesis and the H1. Who wanna try? This is not good. It's too long. So tell me how to state the H1. So we got, this is step 1, H null and H1. Okay, how to do it? If you have this data, what can we say? How to write the H1? IUM wants to know whether the gifts are equally well liked. So how to write it?
For H1, F observed linear equal with frequency estimate. For H0, F observed equal with FE.
So you can write H1 the observed one not equals to the expected one. Is that what you want to say?
Yes.
Okay, yeah, you can write it this way. And then because equal, right? So equals should be H null. It shouldn't be H1 because in H1 you cannot have equal sign. And then you can have observed equals to expected. You can have this. You can also write what else? You can say that where is it? Whether the gifts are equally well alike. So you can say the gifts are not equally well liked, and this is equally well liked. You can write it in words as well. If you look at the textbook, how does it look like? Okay, because the textbook normally will just give you one options of answer, but basically the answer are a variety. Okay, so let's see how does it look like in the textbook. It puts here is that the proportion are not equal, and then proportions of 1 equals to 2 and 3. Even though you are not talking about proportion here, right? This is like the examples of frequency. We are not talking about proportion, but these answers are actually not accurate because we are not talking about proportion. Okay, but the not equal part is correct. I just wanted to show that sometimes you can also combine the H1, the hypothesis, the step 1, with 2 different ways. Means that if you look at here, the H1 is in terms of words, but the H null is in terms of statistical form. So you can also combine statistical form and the words, but I don't prefer this. Okay, even the proportion is not correct, because we are not talking about proportion. It's better if you want to stick with the statistical form, stick with statistical form. If you want to go for words, go for words. But it is not wrong to combine the statistical form and the words. It is not wrong. Okay, just to let you know. Okay, and then you compute whatever the blah blah blah. Okay, that's it. Okay, second question. If I go too fast, please let me know. Okay. Oh my god. I think someone is calling, and I have a parcel. Okay, did I record this? Yes, I did. UM employs 60 technicians and records the types of most recent visit to a hospital by each employee. The Department of Statistics found that 53% of all medical visits were to cardiology, 53% to cardiology, 19 to oncology, 17 to neurology, and 11 to blah, blah, blah. You want to know whether IIM data differs significantly. So it's not equal. Differ means not equal, right? From the national data conducted by DOSM. At the 0.01 significance level, compute the test statistics. Can you compute this? What is this? What is this? Is this proportion? Is this goodness of fit? What is it?
Also goodness of it.
Goodness of fit. Okay. Yes, it is goodness of fit because you can see the number of visits. It's the number of visits is like frequency, the number. Okay. So in proportion, you don't have something like this. So how to compute it? What is the formula? I don't remember. Goodness of, this is goodness of fit for, okay, goodness of fit you have to equals and not equal. What is this?
Not equal.
Why?
Because the question give the percentage.
Okay. When they tell you it is equal, like, yeah, it is. But here you can see that you have the observed number. This is what we can observe, right? And then this is the percentage, like the number given by the national data or Department of Statistics. Means that they will have a different value. So how to compute? So as I mentioned to you, for the goodness of it, the trickiest part is to compute your, this is FO, this is FE. So what is your FO? Tell me, observed frequency. What is your observed frequency?
29, 11, 16, and 4.
16 and 4. You shouldn't get it wrong. This should be right because it is there. Observe means the number that you can observe. So how to compute the expected frequency? Now,
The percentage multiple by the total of number of visits.
okay. Yeah. So if I wanted to write the percentage, but this is not observed, right? Means that this is not 53%. You're given here 53%, and then 19%. What else? 17%, and the last one 11%. This is not the expected because you cannot compare the number with the percentage. So what you can do is that take all this number, multiply with how many n? 60, right? So you have to multiply with 60 so that you will get the value for each of them for the expected. Got it? So I believe that you should get the right answer. I don't know what is the value for 0.53 multiplied with 29. 15. Is it 15? Oh no, it is. It is right. Is it 15.3? Did I compute it correctly?
31.8.
31. Oh, okay. Is it 20? Oh, okay. I 0.53 multiplied with 60. I said 60, but I put 29 in my calculator. That's why. Okay. Okay, you should get, this is what happens when you are talking and then you are calculating and then you are writing as well. That's why. So you should get 31.8%. The 31.8, it's not percent. Means that 53% multiplied with 60, the number, and then you should get the number value. So now you can have number compare with number. That's fine. Okay, means that it is comparable. Previously, you have percentage and number. You cannot compute this way. Okay, so do it for all. So you should get the value. I'm not sure what are the whole things, the whole value. Okay, so if you have computed it, then you should get the second value 11.4, 10.2, and 6.6. Okay, and then if you want to use this kind of format by putting them into a table, which you shouldn't, you can just simply apply this whole thing, like observed frequency minus expected frequency, and then put squared into your calculator, and then you divide it with expected. So you will get the answer straight away. Okay, instead of computing it one by one. So if you're computing it one by one, it will take you some time. Okay, but I'm afraid that you will do this. That's why I give you like 10 minutes. It shouldn't take 10 minutes, less than 5 minutes. Okay, so you should get 4.58. So you have to give me like 1 second to charge my laptop. Okay, done. So any questions so far? Is it clear?
Clear, madam.
Clear, right? It was very direct and very simple. Okay, so what's next? Yeah, you should get this answer straight away. You should give you 2 marks. Simple as that. Okay, so now let's see. Do you have any question? I mean, anything you want to ask? So how does the, I didn't copy the full sentence. Okay. Okay. Let's see the question for the previous section. Give me 1 second. Okay, sorry for that because well, GNT. So they keep calling me, so I have to pick up the phone. Or else, well, I don't know. Okay, sorry for that. Where are we? So, can you hear my voice?
Yes, madam.
Yeah,
Yes,
cool.
madam.
Okay. Because I wanna open this WhatsApp. Okay, cool. Take some time. While waiting for that, let me open a new one. Okay, where is it? Section. Okay, so section 1 and then section 2. Okay, cool. Okay, so let's see question for section 1 first. Okay, so let's do this together. According to a study conducted by the IIUM, 63% of IIUM students have cats. Is it true? Not sure. You personally think the data is not correct. Perhaps you think that, well, many people will have cat. Maybe it's not 63%. Could be like 80%. I don't have cats. And prepare a report for MSAS for their voluntary activities as part of. So what is this 63%?
Pi.
Wow, cool. You have a very good study. So, so pi is 0.63. As part of the reports, a random samples of 300 students showed 210 have cats. So what is this 300? Wow, okay, cool. And then showed 210 is what?
X.
Yeah. Yes, this is your observation. Out of 300 sample, you observe that this is your X, 210 have cats. So using 0.05 level of significance, this is your alpha, 0.05. You should state the null hypothesis and alternate, and then compute the test statistics. So given this whole information, what formula should we use? Should we use goodness of fit? Should we use proportion?
Proportion.
Why? Why? Because you are given x and n, and then pi as well. Okay, so under proportion. Okay, so let me see, under proportion, you have one sample test and two sample tests. So what is this? Is this one sample or is it two sample?
One sample only.
Yes, one sample, because you only have one n and you only have one x. So it should be one sample. If you want to talk about two sample, then you're gonna have like two things. You're gonna have 2n and 2x. Okay. So what is the formula? Oh my god. The formula, this one. Let me just write the formula. The formula is z equals to proportion minus pi over square root of, this is pi, 1 minus, is it pi as well? Yeah, because it looks like x to me. Pi over n. Okay, now, can we compute the z? Oh, before we compute the z, state the hypothesis, H null, H1. So how to state it? How to state it?
H1 pi not equal to
Okay. Not equal to what?
0.63.
H1 pi not equals to 0.63. While the H null, the pi should be the opposite, equals to 0.63. Okay, this is the precisely the for your hypothesis, step 1. If you don't know how to write in terms of this form, you can say that H1, the proportion, does it mention proportion? No, it doesn't mention, right? Let's assume that you don't know this is proportion. Let's assume that you don't know that n and x will give you proportion. So let's see where is the parts. You personally think the data is not correct. Okay, so you think that whatever given here is not correct. So you want to compute your own. So you can say that what is it? So you can say, instead of proportion, percentage. Right, you can say percentage. The percentage given is not correct. You can write percentage given is not correct. Okay, so you can rewrite the question. And then the H null, the percentage given is correct or equals to whatever. Just assume that you don't know that you are referring to this 0.63. Well, as I mentioned to you, the step 1, when you want to write the hypothesis, is very flexible. It's not necessarily that you have to understand the statistic. It's not necessarily that you have to know this form. Okay, you can write it in terms of words, and you can also combine the words and statistical form, which I don't really like. Be consistent. If you want to write in terms of statistical form, maintain it. Okay, even though the textbook will combine whatever. Normally textbook will just put all the answers like whatever. Okay, so it's clear. So second, compute the test statistic, right? So second, so you are using z. So how to compute this p? What is this p?
S divided by n.
Okay, p equals to x divided by n. Your x is what? 210. Your n is 300. So what do you get by doing that? Do you have your calculator with you? 210 divided with 300. So you should get
0.7.
0.7.
0.7. Okay. So, yep. So 0.7. Or maybe you can just rewrite here. 210 divided by 300. It's up to you. Okay. And then minus, what is this pi? This one. Right? So 0.63 over the pi as well, which is, what is your pi? 0.63 multiply with 1 minus 0.63, and then this, you have a square root here, and then this divided with n. What is your n? 300. Given all this working, I don't know what is the answer. I don't want to compute it. Let's just look at the answer from textbook. I hope that you know how to compute it. Okay. Given, is this one? This is number 2. Yeah. Given all this working, you should get the value of, what is it? 2.51. Okay. 2.51. Any question regarding this? Is it clear? No.
Clear.
Easy, right? Easy peasy. Okay, all the questions should be easy. Okay, second question is this. Okay, for your project paper in ECON1140, I hope that you know what is this. You conducted a study on accident rate among Malaysians. Random samples of 400. Okay, so what is this 400? Samples of 400, what is it? What is this 400?
N.
And for males, reveal that 120 had at least one accident in the previous 5 years period. So what is this 120? You observe
X
that,
for men.
yeah, you observe that they have accidents of 120. So this is X. Okay. Similarly, a samples of 600 female. Oh, now you know that you have 400 males, and then you're comparing with 600 females. So you can see that you have 2n here. So the first n is 400, the second n is 600. So instead of making you confused, don't just leave as n and x and n at x again. So label it. This is maybe n1, this is x1, this is n2, and then later on x2. Or if you want to make your life difficult, maybe you can write n for male, x for male. It will be like time consuming. Just put n1, x1, and blah blah blah. So x2, and reveal that 150 had been in at least one accident. So this should be your x2, 150. What else? At the 0.05 significant level, this is definitely your alpha. State the null and alternate. Okay. So you know that you have 2n here. I mean, you have 2 sample. Okay, so, and you are given n and x. So this refers to proportion. So this information should clearly direct you what formula you have to use. Okay. Whether it is 1 sample or 2 sample, it should tell you exactly what are they. So how to write the hypothesis? Tell me. H1? H1. What should we say? Is there any equal? Is there any difference? Is there any bigger, larger, smaller, whatever? Can you see somewhere? Anyone? No? So you can see that you conducted blah, 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 a random sample blah, had at least one accident, blah, blah, blah. Similarly, samples of blah, blah, blah. So what is our H1? Anyone? How to write the H1?
Is it pi 1 not equal to pi 2?
So pi 1 not equals to pi 2. Yeah, this is correct. Okay, so the question should tell you whether this is difference or not difference, but since it is not given there, so you have to assume that when you have 2 things, when you have 2 samples, sample 1 shouldn't be equal with sample 2. But because we are talking about proportion, so a proportion is pi, right? So pi 1 is definitely not equals to pi 2. And you can also write pi 1 equals to pi 2. Okay, so if you don't know how to write in terms of this form, statistical form, you can say that because this is proportion, right? So well, proportion 1, or you can say that the data for female is, okay, data for male is different from or with the female. Okay, so you want to say that when you have two things, they should be different from each other. Okay, so this is how you want to state the hypothesis. So that is the first question. Second, compute the test statistics. What kind of test statistics? And what is the formula? What is the formula? What is the test statistics? Anyone? So this is for one sample. Since we are talking about two samples, yeah. So let me just rewrite it here. You have to compute PC and then x1 plus x2 over n1 and 1 plus n2, and then you have the z here. So P1 minus P2 over quite a bit long working, but they are not that hard. So you have PC here, that's why you computed earlier. 1 minus PC over the N1 plus PC. 1 minus PC, PC over N2. Okay, now you have the formula here, that's good. So before computing the z, you have to compute the combined proportion. Okay, so c is combined. So x1 is given, right? So what is it? 120 plus x2. What is x2? 150 over n1. Where is n1? 400 plus n2, 600. So if you have this working, you should get the value of, what is it?
0.27.
0.27.
27.
Yeah, I hope that this look correct. Okay, and then how to compute P1? How to compute the proportion 1? Remember what is the formula of P? P is
X over N.
because we are looking at the first proportion. So find the x1 over n1. What is the x1? 120 over, where is the n1? N1, this one, 400. So this will give you the value of P1 and do it for P2. Okay, what is the P2? X2, 150 over N2, 600. And this will give you the value of P2. And you have computed the PC, which is this one, and just plug it into the formula. You should get the answer straight away. So let me see the whole answer because I don't want to compute it. Yeah. So the combined proportion, definitely. The x1 plus x2, n1 plus n2, you should get, yeah, as your friend said, 0.27. And then this is the proportion for male minus proportion for female. And then just take the formula. What is it? P1 multiply with 1 minus P1 and then sample for 1 and then sample 2. And then you should get 1.74. Okay. So basically, once you have listed down all the information, you just plug into the formula. You should get the answer straight away. Okay. So is it clear?
Clear, madam.
Clear. Hope so, because the question is easy, right? So now, since I have explained 4 questions, so anything you want to ask before I want to stop the recording? No.